Well, thank you very much. Can you hear me okay? Okay. I think Fausto has introduced me, so I'm not going to talk about myself. But I was really fortunate to have known Fausto and Anselmo, Professor Fritz. I really have a very good connection with ITA. So the past 6 years we have been collaborating on several research projects. So it has been really a pleasure for me to come back to Brazil again. This is my second time. And I look forward to coming the third time and giving a presentation in Portuguese, okay? So that's the next goal. It's a challenge, right? Yeah, okay. So today what I decided to do is, instead of talking about the research that I do, I'm going to tell you a little bit about one of the challenges that we are faced in the United States when we are educating the future engineers. And most of the challenges in the old days, we teach students to memorize equations, right? And then the exams are all about memorization, mathematics, but things are changing now. The current generation is really more computer-oriented, right? Reading is on a tablet or on a phone. So we have to find different ways to interact with the future generation of engineers. So there are some initiatives in the United States that are focused on what we call competency-based education. And the idea here is, instead of just memorization, if you can give students some challenge that they have to work on, and then at the end of maybe their semester or at the end of the year, if you can push them to learn in a lab setting, or you send them to the industry, and then they look at a problem, maybe they will develop a prototype for the solution. So it's more learning by doing instead of learning by memorization. Okay? So today what I'm going to explain to you is some of the frameworks that we are trying to use in the United States, and hopefully this will be useful. I'm pretty sure you are already doing it here in ITA because you already get, excellent students to begin with, right? They've told me how difficult it is to get to ITA and the public institutions in Brazil. So the students are prepared, but how could you challenge them further to see their potential, right? And I was actually surprised to hear from Professor Fritz and Professor Rene, their first year engineering students really are doing some amazing hands-on experiments. So what this does to you is, maybe if you don't have the framework, you can take a look at this as, okay, if I'm already doing it, but can I put it in this framework? Okay. So I will explain to you the first thing, this is my outline. The first thing I'm going to talk about is what's called the National Academy of Engineering Grand Challenges. So these are problems that international experts think are the 21st century problems. So whenever you are thinking about assigning a project to students, you can think about the problems in a grand scale, and we'll go through the NA grand challenges in today's talk. Now, these grand challenges are organized in 4 different areas. The first one is sustainability. And then we have, of course, security is another major issue in the world. And we have also health issues that we have to address. And of course, the last one is, if everything is perfect, let's say, we are able to live indefinitely on Earth, or we are secure and we are healthy people, well, humans are restless. Yeah, we always want something to challenge us. So the joy of living. So there are problems along the joy of living that we have to address if we meet all the above 3 requirements. And then I'll show you some simple teaching examples that are being taught at Arizona State University, and the reason I picked that is because it's already published. What they are doing is published, you can find it easily. But a very quick conversation at the end. Okay, so just to give you a little bit of history, in 1998, the National Academy of Engineers and the American Association of Engineering Societies got together, and then they talked about, okay, what did humans achieve in the 20th century? Okay. So this is just looking at more what we have done in the past century. So the documentation of all the great achievements that humans have. If you really get the opportunity, I highly encourage you to read this book, because it has so much historical information about a lot of the inventions that happened in the 20th century. And it's a relatively very easy book to read, not complicated, not technical. Yeah. And of course, I mean, Brazil as a country also have played a significant role in some of the achievements, like, for example, aerospace, right? I think it's a good read if you get time to read it. So what they did is, these organizations got together and they developed this book, and they tried to categorize the innovations in 20 categories, so 20 major achievements, okay? But to give you a little bit of a background about National Academy of Engineers, in the United States, this is a group of highly recognized experts. They give advice to our politicians or to even academic institutions. They are independent, so the government can tell them what to do, and it's also a voluntary service. So people really believe in it, so they give their potential to work on this. And it's very highly selective, so you need to accomplish a lot of things before you become a member of the National Academy of Engineers. So the reason why I'm telling you this is, if engineering is supposed to be the leader in any country, I mean, you need to have some leadership, and these are the people, at least in the United States context, that are providing the leadership. Yeah. And really, their advice is, the most important word is independent. So it's independent advice involving anything from engineering to technology. Yeah. So the 20 greatest achievements of the 20th century were listed here. Again, I'm not going to read every one of them, but obviously you can see that things like the internet, yeah? We can't live without the internet now, right? So that's the 20th century achievement. You know, the highways that we see, the major highways, the way we think about designing highways nowadays, you know, that was started in after 1950s, right? The major arterial highways, or radio and television, airplane, automobile, and I'm pretty sure Brazil has again participated in the innovation of some of these achievements significantly, right? So maybe this is a question, Fausto, that you will translate for me. So which one of these 20 achievements do you think Brazil has contributed the most? Airplane, right? Does everybody agree? I'm trying to make the lecture more interactive, okay? So it doesn't. So you say airplane is number one? Okay, what about number two? If airplane is number one, what about number two? Agricultural mechanization? Would that be a fair statement? Petroleum, right? Okay. Yeah, so from my perspective, it would be hard for me to say which one is number one, number two, number three in Brazil. Oh, okay. Yeah, but the whole idea of putting this in this type of framework is for you to think about, okay, My country, let's say Brazil, has contributed to these different areas. In some areas, it would be at a bigger scale. Maybe in some areas, we didn't contribute that much, but as we move to the 21st century and we have new problems, of course, Brazil is a big contributor to the world. So you will be leaders in some of the areas that are important for our life in the 21st century. So this gives you more, again, a past outlook, but moving forward, what are the challenges that we think are larger in the world? So it's always difficult to characterize, problems in one line or two lines, right? So what they did is, by the way, if you have more interest, this is a very good website. It's greatachievements.org. So in each one of the 20 achievements I have shown you in the last slide, you actually can get more description of, I'm just showing you one example here, because in the last slide, by the way, the order is not important, okay? It's the way it's listed on the book. So if you look at electrification, it will tell you when it started and who are the big players like Thomas Edison and Nikola Tesla, and some of the major milestones in electrification is given to you. So you can click on the 20 different achievements and we'll get more information about each one of them. Now, so remember that one was in 1998. In 1998, reflecting between 1900 and about 2000. So once we passed 2000, the same group of engineers, the National Academy of Engineers, they got together with the National Science Foundation. The National Science Foundation is an agency in the United States that gives out money for researchers to do research. Okay. So they get together in 2006 and they started a new initiative. And in this case, the question was, what are the larger societal problems that we are faced in the 21st century? And so let's summarize those problems of the 21st century. That was their goal. And of course, this really depends from country to country, so that to make sure that they are not biased, they actually invited international experts this time. So the group who came up with what are called the grand challenges are not only people from the US, it's people from all continents, okay? And really their main goal was, this is a quotation from the report, it says, we're not just thinking about what could be invented, but rather focused on what needed to be developed. Sometimes it's not only the inventions, but what could be developed that will lead us towards the inventions, okay? So don't think in terms of only products like airplanes or automobile, right? So those are products or inventions. But when you think about the joy of living, it's not necessarily about products, right? Sometimes what we lack is not necessarily product. So this is an important characteristic of this initiative. Okay. Now, you may wonder, why are engineers only doing this? Well, you need to have some representation. Of course, there is another agency called the National Academy of Scientists. There's also another entity called the National Academy of Medicine. Okay, so, well, from the engineering perspective, the two main goals are, we want to know, or we want to orient the public, we want to draw the attention and telling them what engineers can play in the society and what their major roles are. That's number one. And then really the second one, which I think is important, is it just gives you a framework. And this framework, even if I'm presenting it today from the education perspective, It could be a company can look at this and say, we're doing excellent work in this specific area, but that actually is part of solving a larger societal problem. Okay, so it gives you really a different way of thinking about what you are doing or even what you wanted to do down the road. Okay. So the short name that's given to these problems is grand challenges. Okay, because we have so many challenges, we cannot list all of them, but we can characterize the most important challenges as grand challenges. And there are 14 game-changing goals for improving life on the planet. That's what the committee came up with. And when you are describing this, we want to make sure that we are grouping them together. So you'll see the discussion among 4 different categories. Okay. So what I decided to do is, before I show you what those 14 grand challenges are, I'm going to have a question. And Fausto, I mean, again, feel free to translate this for me, for people who may feel comfortable to hear this in Portuguese. So I want you to think about 2 or 3 major engineering challenges that the world is facing now or will face in this century. Remember, you can't say in the internet, automobile, or airplane, right? Those are the 20th century problems that we have solved already. So, and then once you think about the 2 to 3, I also want you to think about, the first one is more looking at the world. But the second question is, what about in the Brazilian context? Because maybe there is a problem that's very big in Brazil and it's not a problem elsewhere, right? So just take a few minutes to think about 2 to 3, and if anybody is willing to share, that would be great. All right, so can you, do you mind giving them a mic? And while you are answering, if you don't mind telling me your name, so.
Okay, Lieutenant Commander Marco Sil from Brazilian Navy. Okay. I said trash management. I think is the big.
Trash management.
Yes.
Okay. Great. And is that also in the Brazilian context or in the world context? In both. Okay. Anybody else? Okay.
Also in Brazil.
Yeah, he said in both the world and in Brazil.
I think in running to space, for example, the space running, we have US, you have India now that's possible to launch satellites, and it's also a challenge for Brazil.
Okay, so you're saying maybe launching to space?
Launching to space, yes.
Okay, and do you mind telling me your name also?
Carla, Major Carla.
Major Carla, okay,
Yes.
Thank you.
You're welcome.
Bruno?
Yes, my name is Bruno. I am for R&D industry, and I believe the electrical matrix, not on distribution, not only in Brazil, but all worldwide, and I believe it's, as he said, also a problem of management, a challenge that we should focus on distributing how this actual intelligent energy should be distributed.
Okay. So thank you very much again for answering. I greatly appreciate that. So now, as I go through the grand challenges, you'll see that your answers can actually fit in a larger scheme, okay? Because there is no right or wrong answer when it comes to challenges. It's the level of the challenge that makes the challenge a grand challenge for the world. But so the next conversation would be, so now you have some idea here. We'll talk about the 4 different groups, and each one has several grand challenges listed. Okay. So these are the 4 cross-cutting teams. For example, he said trash management, right? Now, where would that fit if you think about this list? Sustainability, right? And she said, you know, like going to space, right? Where would that fit? It's security, right? And Bruno talked about the electric grids and energy, right? Where would that fit in? Well, it could fit on the sustainability, or it could fit in the joy of living, right? Yeah, so I mean, again, the whole idea here is not to say, you know, one challenge has to fit in these 4 categories. Sometimes some of the challenges can actually be mapped into several categories, right? But at least it gives you a framework of thinking into sustainability, security, health, and the joy of living. Okay. Now, these are the definitions that are given by the NAE folks. And so when we talk about sustainability, is our ability to occupy this planet continuously. Sometimes people will say indefinitely, but you know, people have different opinions about that. But it's the idea that at least, hopefully, the next generation would survive in this planet, right? We always like to think in that manner. Now, security is, of course, guaranteeing security from major threats and hazards. And as she mentioned, it could even be competition, right? Competition can be a threat for a nation's security. Okay. And health, of course, we like to live as long as we can. So inventions along the lines of medicine or medical imaging and the like are important. And then the last one is the joy of living. I think this is what a lot of people did not think about initially, but the more you read about it, it actually makes much more sense. Particularly if the nation is strong in making sure all these 3 are satisfied, well, then what do? Well, we have to enhance joy for people, right? And then there's always this question about, you know, the human existence and understanding people, interacting people. Those are very important, again, elements. So joy of living is an important factor as well. So what I like to do is, it will take me, if I cover all the 14 areas, it will take me several days. So I'm going to focus on some of them in depth. Some of them I will only show you one slide. And Fausto, do I have to take a break what time? Okay, or if the audience is okay, I can also cover and we can go, whatever is easy. Is that okay? Or do you want to take a break? I have 10 minutes for the next round? Okay, so you'll tell me that, right? I don't have a watch. Okay. Okay, so in terms of sustainability dominating teams, again, I'm putting a number here for you, but the report did not say this is number 1, okay? It's the order is really random, but I'm just putting numbers so you can follow easily. I'm not saying this is the number 1 challenge. Well, the first one is developing carbon sequestration methods. We need to capture carbon dioxide and store it safely, and whenever possible, even reuse it to make new products. Okay. Again, there is a, if you think about the industry that produces a lot of CO2 to the atmosphere, one of them is cement production, right? Cement production emits a lot of carbon dioxide to the atmosphere. So one of the research activities in the US, particularly in the Southwest, is can we actually make concrete that you see around without putting cement? Is it possible to have concrete without putting cement. Because if we are able to do that, if we are able to use less cement, that means less production of CO2, less emission of CO2 to the atmosphere, right? So there is actually a concrete called polymer concrete. Right? So by putting polymers, you can actually take out cement. And there is progress already made, significant progress on producing polymer concrete. There is an international organization that just meets to discuss polymer concrete. Okay. Now, and it's getting more attraction by the year. The only challenge is, as you know, polymer in terms of like the fire protection, you know, there is still work that has to be done. It's flammable, right? So, but there is a tremendous significant progress in, again, taking out cement from concrete production. But, you know, we'll still produce cement. It's just the amount may be small. So can we capture that CO2? That's one question. And we can do two things. One is we can capture carbon dioxide when our manufacturing plants, industrial plants, whatever waste we have, we can capture it at point source, or we can capture it from air. Okay. There are already existing methods that are, available for carbon sequestration. This is a nice picture just summarizing what I said earlier. Again, you can capture it from your industry directly or from the atmosphere, but the challenge is you need to transport it. So some of the challenge when you think about this is once you capture it, you have to transport it to some other storage place, right? So you need to build the infrastructure necessary to do that. And then it's not only storing it, I think reusing is important, like in the polymer concrete area, right? Sorry, not polymer concrete. You can use CO2 in other spaces, but then you have to come up with that utilization scheme for the particular problem. Just to give you some, again, challenges, well, obviously it's a costly operation. So countries or towns or states have to be able to cover the majority of the cost. You need to have, again, infrastructure development, as we talked about, particularly the transportation and the storage piece. And then the last one is the community engagement. The community has to believe in that. So if you, we have a course that we teach our students called risk communication. Sometimes it's not only coming up with plans to reduce threats or hazards, but you have to send people to the community to explain to them why a particular solution is better for them or why a particular solution is applicable to their region, right? So communication is, with your community is a big piece of what you need to do when you are thinking about solving grand challenges. Some policy considerations, of course, Bruno talked about R&D, research, development, and demonstration. That's always important. So the National Science Foundation in the US, we ask them to give us more money so we can do more research. We need to develop standards. Okay? What is the standard of storing it, or what's the standard of transporting it, and so on. And I think I don't want to read everything, but strategic siting. If you're transporting it or if you are storing it, where are you doing that? Who's giving you the land, right? Getting the permission, the land. Could be controversial. I'm sure you guys have heard about, in the US, they are trying to put pipelines in some communities, and then some communities would say no. I mean, maybe this is a cultural place that we don't want this to cross our land, right? So there's a lot of back and forth between the community needs and the needs of solving the grand challenge. And of course, I mean, if people are able to generate a solution and then that solution is being used, Are you giving incentives for people who are using it? Okay, so that's also important thing to consider is modifying the incentives. So in the Brazilian context, what challenge or opportunities exist for developing carbon sequestration methods? I'm trying to learn because I know I'm teaching, but I'm also trying to learn. Or is carbon sequestration not necessarily a priority for Brazil? Okay.
I think this is a priority in Brazil. Yeah, this is important for, we have a great potential to capture carbon and also to produce green hydrogen. That's same, it's almost the same energetic metrics to discuss.
Right.
So I think this, but that's a challenge to developing carbon sequestration methods because it's not quite easy to perform this kind of industry here.
Yes. Thank you. Fausto, should I continue or should we go for break and come back? Maybe. Yeah, I think let's have a break. I only have maybe another 20, 25 slides, but it will go faster because some of the slides are just questions. Okay. Thank you.